Remember, sometimes less truly is more in multi-tenant systems. Managing models at massive scale. Automation first. Automate everything. Training, validation, deployment, and monitoring. Like a smart factory that runs itself. Minimal human intervention needed. Tools include MLflow, Kubeflow, and CI/CD pipelines. Model registry. Centralized catalog of all models with versioning and metadata. Like a library system that tracks every book, edition, and location. Features include version control, performance tracking, and lineage. Resource optimization. Smart resource allocation and sharing across models. Like traffic management, route resources where they're needed most. Strategies include model sharing, batch inference, and spot instances. Monitoring at scale. Automated monitoring and alerting for model performance. Like having a doctor monitor hundreds of patients. Automated alerts for problems. Metrics include drift detection, performance degradation, and resource usage. Scale requires automation, organization, and smart resource management. Getting multiple models to work together in production. Deployment strategies. Parallel serving means run all models simultaneously. Sequential serving means chain models together. Lazy loading means load models only when needed. Like conducting an orchestra, all instruments play together to create beautiful music. Performance considerations. Latency includes parallel processing versus sequential. Memory includes load balancing across instances. Fault tolerance includes graceful degradation if models fail. Now, let's look at the code example. This demonstrates how to combine predictions from multiple models to create a more robust final prediction. Ensemble deployment requires careful orchestration for optimal performance. Keeping all your model pieces working together. Dependency hell. Common problems include version conflicts between models, different Python library versions, OS-specific dependencies, and hardware-specific optimizations. Like trying to mix Lego sets from different years, pieces don't always fit together. Impact includes models that work in training, break, and production. Solutions and best practices. Containerization includes Docker containers for each model, include all dependencies in container, and reproducible environments. Environment management includes Conda virtualenv for isolation, requirements, TXT pinning versions, and environment.yml for reproducibility. Version control includes tag-compatible library versions, automated dependency checking, and gradual migration strategies. Now, let's look at the pro tip section. Test in production-like environments early and often. Dependency management prevents production nightmares. Models that learn and adapt in real time. Implementation challenges. Data drift means input distribution changes over time. Concept drift means relationship between inputs and outputs changes. Catastrophic forgetting means model forgets old knowledge. Like surfing, you need to constantly adjust to stay balanced on changing waves. Safety mechanisms. Gradual updates with small learning rates. A/B testing to compare new versus old model. Rollback for quick recovery from bad updates. Human oversight to monitor critical metrics. Now, let's look at the code example. This shows how to safely update a model in production while monitoring for problems and maintaining the ability to roll back if needed. Online learning requires careful balance between adaptation and stability.